far, in Pandas, we filtered data, grouped it, and optimized memory. But now comes a very important shift. Today, we are not just writing Pandas code, we are learning how to think while querying data. This is Pandas Advanced Part 5, Advanced Indexing and Query Thinking. Most bugs, wrong results, and confusion in Pandas comes from indexing mistakes. Once you understand this properly, Pandas becomes calm and predictable, okay? So, I need to make a simple data set, just we made in last classes. Okay, so we're just moving to make a data set. Import pandas as PD, and we need to make a data set with data equals curly braces, employee. Then we are making through a dictionary, Alice, Bob, and we are using Bob, Charlie, all these names, just like the previous data set. Okay. So this is a clean employee dataset, simple but realistic. Exactly what we see in real projects. So this is what we always make, and we are just using the same dataset because to get used to it. Okay. Now we are doing index vs position, which is very important. Okay. This is the first mindset shift a person should have. There is two types, that is iloc and loc. Loc work with labels, but iloc work with positions. So let's do it. First of all, we are just giving df.iloc and placing 2 inside it, run. And afterwards, we are going to do df.loc with 2 inside it. Okay, we are using both. As we see here, so while you see this, and I can also do this one, here we get both as employee, Charlie, department, finance, everything same. But the operation behind it was really different. Here I used iloc, which really work with positions. And here, just loc, which work with labels. Even if they look similar now, they behave differently once indexes change. Okay. So I want to do this. Okay, selecting rows plus columns together. Okay. So if we select df plus iloc, and then we are adding df, department, and I'm adding, which is, I'm assigning that it's IT, and then I'm using a comma to separate it, and just placing the employee with the salary. Okay, so this is analyst-style pandas. Okay, here we get employee department, salary, and experience. First one is Bob IT 70 and 5. Second one is Eva IT 52 and 3. The first filter rows and the second choose only what you need. Okay, this keeps your result clean and readable. As you see here, it just filtered, it gives a condition by assigning the department as IT, and then it gives what we need. We need the employee name and the salary, and we get the both from IT department. Okay, this is how it works. And we can also use multiple conditions in the right way in the same snippet of the code. Okay, as we see here, we just make things in we just go through this, but I know it might be a bit confusing while knowing more about iloc and loc. So let's do an example on that, so your confusion will be much more clearer. Okay, for that I'm going to create a new data set, but we are using the previous one with a different name. Okay, so let's keep it below this code. So we print this here, and then we name this data as datas. We don't want everything, but let's add the employee and the salary. We don't want department and experience for now, because we are changing the dataset name. Okay, so now what I'm going to do is, here df equals pd dot data frame with datas. Okay, so here I'm using, so like we do, we just place that variable or our dictionary in pd.data frame, we call our df, and we run. Okay, so it's run like every time, but before that I'm just using index and placing index equals in a square bracket. I'm using 101 comma 102 comma 103 comma 104. Okay, so let's see what happened. We have 1, 2, 3, 4, 5, 6 values. We only give 4 values. Okay, so here we got a value error because here it's clearly written that x6 values does not match the length of index 4. Yeah, okay, fine. Let's add some more and 106. So it fit the value and the index numbers. Okay, so we have index names 101, 102, 103, 104, 105, and 106. Okay, so notice something important. The index is 101 to 106, not 0, 1, 2, or 3. This is where iloc and loc behave differently. Okay, if we take loc, that is label based, what happened? Just go through that. We can do it by df dot log, and then we can add 102 and run. Okay, so here we get the 102 as Bob, as we see here 102 Bob 70. Okay, now here you can see how log works. The log look like the label 102 in the index. It does not care about position, so it care about the index. Okay, so now we are talking about iloc, which is position based. Just remember, it's so simple. Loc is based on label and iloc is based on position. Okay, let's do iloc, tf.iloc, and we can place one here. Okay, and run. So here we get Bob because Bob is in first position. Okay, so iloc look for second row because indexing start from 0. It completely ignores the index labels. Okay, so these are index labels and the positions count as Alice in 1, Alice as 0, Bob as 1, Charlie as 2, David as 3, and Eva as 4, Frank as 5. So it differ. How it differ? Index labels are taken from log. We use log to get the index labels. Here the index label is 102. Okay, but in case of iloc, it take index positions. Index position is start from 0, 1, 2, 3, like a way. And if we do a side-by-side comparison, let's do what happened. Okay, if we are doing df.log with 102 and df.iloc with 102, what happened here? So you see here, right? Now, if we run, we will definitely gonna get the error. Okay, so we get the index error, single positional index error is out of bounds. So this is why beginners get confused. If we use index is in 0 based, if iloc 0 will fail. Okay, here we got the index error because this is different. And while we go through this, this line works because 102 exists as a label, but this one fails. I mean, it works because it's a label and the label equals 102. But if we run this one, we will get an error because what happened here, it look for position. The 102 position is not available in our code. Because of that, it will create a error like we get an index error that the positional indexer is out of bounds. So it's not found. Okay. But this is how a person should understand the difference between log and iloc. Okay. If there is iloc, it is index location. Okay. We can take index location, just log, just label. Okay. So keep that in mind. And here pandas try to find the 1 seconds position which doesn't exist. Like we see here, it's out of bounds. Okay. So I hope it's clear. And if we go through the range behavior, we get I'm placing this error as this way because to understand and to know what happens in each code. Okay. Now I'm using df.log with 101 is to 106. Okay. If we run this, we will get all our things, all our label names, employee salary, all that. And if we use df.iloc and then we place 0:5, we will get just like that way. Okay, we get 101, 105 till 105. Okay, so we get till 105 because the last one don't count. Okay, if we give a 6, we will get the franc. Okay, so we already discussed these basics in our previous classes, and I just rewind it because loc and iloc work really different, and you should know while you are advanced or intermediate or basic, you should know what's happening there. This is how the critical difference. Iloc includes the end label. I mean, loc includes the end label, but iloc excludes the end position, just like Python slicing. Okay, so if we give till 5, it just excludes the end position because it's integer location. But if we use loc, it just includes the end label. It counts the end too. Okay, so that's it. Now you can just keep it in mind like iloc label, index location or position, and dot loc labels. I'll also just place it as a text. Iloc labels and I'm sorry, iloc position, or we can say index location, and just dot loc. Okay, don't forget the dot. Okay, dot loc labels. Okay, so you can understand the difference now. This is why beginners get confused. If your index is not 0 based, dot iloc 0 will fail. Okay, so always ask yourself one question: am I selecting by label or by position? That single question tells you whether to use iloc or loc. Okay, so that's all about our iloc and loc. Our whole video is not based on that, but I just explain it because it's important and people get really confused. Even me get confused because I used to say iloc every time instead of just dot loc. So that's it. People may get confused with some tiny codes. Okay, so let's move to our main part. So I will refresh the current part. We just gone through df loc with column. We assign a condition. We placed what we want in square bracket. Okay, that's where we end. And now we are going to look multiple conditions the right way. Okay, so before that I need this to be placed in between because we just changed the df to datas. So before starting our next code, I need to run that. Then okay, now we are going to use df.loc with df department, and then that's equal to assigning finance. We are using a and in between, then adding df salary, which is another condition that's greater than 70k. Let's give 75. Okay, place it in a parentheses, then add our employee and then the salary. Okay, now run. So where do we get the error? We need to go through this. We need to go unhashable types series. Okay, so we need to find where is the mistakes we found. Okay, so let's read it. Unhashable type series. So something is meant to get it as a series. It's not a series. Let's place it under a bracket. That's a square bracket. Let's run again. So we get 5 franc 78,000. Notice the brackets. In pandas, logical conditions must always be wrapped properly. That's where we got an error. We just forget our square brackets. Okay. So this avoids silent bugs, one of the most common pandas problem. Okay, and we sort it in this video. So we understand how loc works, and we placed everything in a square bracket, added 2 conditions inside, separated it with a comma, then add what we want in another square bracket and place or wrap everything properly with another square bracket. Okay, we used many things, but we placed everything in a single snippet. Okay, now we are going to use ease in. Okay, so we are going to use ease in with df.log. Also, we are going to add df with department, and then dot ease in. We are placing HR and then IT. Okay, run this. Instead of writing many or conditions, easyn makes the code cleaner and more readable. This matters a lot in real projects. So easyn give everything, easyn give any HR, IT, all this together. Okay, this is more readable, also much more cleaner code than using many or multiple O's. Okay, so we find how easyn works all this. Now we are moving to query method. It's like SQL-like thinking. Okay, let's do that first. df.query and then add salary with salary is greater than 60k, and we are using experience which is greater than or equal to 5. Okay, run this. So as I said, query let us think almost like SQL. It's more readable for complex conditions and often easier to debug. We just placed everything in a quotation marks, like we really write the code. Okay, we write the English and use some symbols other than using a code or many other complicated things. Okay, which make it much more easier to debug, also easier to read. Okay, so for that we use query, which is more alike to SQL thinking. Okay, and if we use query with variables, which is a advanced thing, min salary, we are using that equals 60k, then tf.query, we are adding salary, which is greater than at min salary. Okay, run it. So the at symbol. Here we find a different symbol that's at. How it works, it allows us to use Python variables inside the queries. Okay, so let's just try. It allows Python variables. Okay, so we can use it in our query. Okay, so this is extremely useful when building dynamic analysis. While you are having a variable, we can just place it everywhere, anywhere in the query, and don't want to repeat everything. Okay, that's really a useful thing. At this level, Pandas is no longer about memorizing syntax. It's about asking what row do I need, what column matters, and what conditions answers my question. This is how analysts think. Now I can show a common mistake. Okay, for that, we are using df and department, then assigning equals IT, then placing closing it, starting another bracket, salary, closing it. Okay, so here we get the salary, one as 70 and another as 52. Avoid using this kind of chained indexing. Okay, so avoid these things. Instead of this, we can use df.log, add df department, and then which is equal to IT, assigning IT, then comma salary. Okay, so we are placing salary and the department. So here also you can see false, comma salary, key error. This you can sort everything out. Okay, don't worry. Okay, now we get the same output, but use log instead. Chain indexing looks harmless, but it can lead to warnings and unexpected behavior. But while we use log, it will be more preferred by professionals. Maybe always prefer iloc. Okay, that's how analysts do. So here use log, which is always preferred. Okay, that's it. So in this video, we learned the difference between log, iloc, how to filter data cleanly, how to think in queries, not just code, why readable index prevents bugs, all this. This mindset is what separates beginners from professionals. Okay. And in part 6, we will go deeper, group by internals, transform vs aggregate, performance awareness analysis. That's where insights really start forming. Okay. So we are forming new insights. We will go through group by, transform, aggregation, all this that we already talked about in our intermediate and in the intermediate place. But here we will talk much more detailed version of all this. Okay. So that's all for today. Okay. And then have a great day, learn it, use it, try to go through all the errors, find errors, debug yourself, and that's how we learn, that's how we grow. So don't get upset if you get many errors, because it's okay to get errors. Only then we will learn, only then we can understand where are our mistakes lies. Okay, so keep going, continuing all this will result in a good level of learning. Okay, see you guys.